Hey guys, we're group 13, and our group project topic is Are the air quality becoming worse or better over the past decade in Beijing? So, next page. The recent pandemic is closely related to each of us, and it is also through this pandemic that people have become more aware of importance of air quality. And therefore, our group plans to take Beijing as an example and conduct some research on its air quality in the form of data analysis. So in this presentation, we will analyze variables related to air quality in Beijing over the past decade and try to answer the question of whether the air quality in Beijing has become worse or better in this period. Next page, please. So, why did we choose this topic? Um, with the rapid development of industrialization and population growth, and the increase of motor vehicles, a large amount of exhaust gas and pollutants are emptied to atmosphere, leading to serious impacts on air quality. In terms of human health, air quality is directly related to this. Poor air quality can lead to air pollution, including harmful substances such as fine particulate matter, SO2 and NO2, etc., which have a negative impact on the human health, increasing the risk of disease and lung cancers. So, this has raised the need of more in-depth research on impact of air quality on human health. And in terms of climate change, certain atmospheric pollutants associated with air quality are also greenhouse gases, and they play an important role in climate change. Studying air quality helps to consider the dual challenge of climate change and air pollution, and to develop sustainable solutions. In terms of monitoring and technology, with the development of monitoring technology, people can more accurately measure and monitor air quality. This provides researchers with more data and tools to evaluate and analyze air quality issues. And then my group member will tell more details.
So let's move on to the data analyze part. We start with the data collection using the AQIC.org website to collect the air quality data from Beijing for the years 2014 to 2024. And this organization uses a total of 6 variables, just PM2.5, PM10, O3, SO2, NO2, and CO. In this data set, PM2.5 is the response variable, and the other 5 are independent variables. In the analyze, the air quality index is represented by the PM2.5 value, with higher values indicating poor air quality. So in the original data we downloaded, there were many blanks as shown in the figure. To avoid the large errors and improve the accuracy of the model, we decided to delete all rows with missing data. And next, after completing the data collection, we begin to read and observe the data using R. And this data set consists of overall 2,831 observations with 6 variables. And then we will analyze the impacts of different variables on Beijing's air quality by building a linear regression model. So for this model, we name it as G. After summarizing the model G, the results are displayed as shown in this figure. And we can see that all the variables are statistically significant, except for SO2, which has a p-value of 0.298 or greater than 0.05. This means that it is not suitable for this model. In other words, its impact on PM2.5 is very slight.
So to talk about this chapter, in analyze, we noticed that the points in the normal quality pilot did not properly lie on a straight line. This is a preliminary indication that our data may not be normally distributed. To further investigate this, we turn to another method of measuring data, the histogram. The histogram provides us with a graphic representative of data distribution and can help us understand the underlying structure of our data. By analyzing the shape, spread rate, and thickness of the histogram, we can gain insights into the distribution of our data and understand any deviation from normality. This step is crucial as it guides us in ensuring the correct statistic methods for further analysis. Next page. To talk about model optimizing, upon reviewing our data, we observed that the majority of points for the variable SO2 are concentrated around 0 or 1. This distribution does not clearly indicate a specific pattern that SO2 follows, making it challenging to incorporate it effectively into our model. Additionally, the p-value for SO2 in our fitted model is not statistically significant, suggesting that it may not have a substantial impact on our outcomes of interest. Given these findings, we conclude that it would be best to exclude SO2 from our model. This decision is aimed at improving the accuracy and the reliability of our model by focusing on variables that have a significant impact. Next page. In our study, we found all variables except SO2 to be statistically significant, implying their substantial impact on air quality. However, SO2 did not exhibit statistic significance in the line regression model, as indicated by a p-value of the f-test greater than 0.05. This suggests that SO2 has a minimized influence on the average air quality. Despite the insignificance of SO2 in this context, it's crucial to remember that it may play a significant role in other scenarios or models, highlighting the complexity of air quality studies. So that's all.
Now let me introduce the residual diagnosis. In our analysis, we conducted a visual examination of the residuals versus fitted values plot. This plot is a crucial diagnostic tool that helps us assess the appropriateness of our model. Ideally, we would expect a random scatter of points, indicating that the model fits the data well. However, we observed an imbalance on both the x-axis and y-axis. This suggests that our model may not be accurately capturing the underlying relationship in our data. The same situation was observed in other plots as well. This consistent pattern across multiple plots raises concerns about the validity of our current model. It suggests the presence of non-linearity, heteroscedasticity, or some other violation of the assumptions of our regression model. Given these findings, it becomes essential to reevaluate our model. We may need to consider alternative models or transformations of our variables to better capture the underlying patterns in our data. By doing so, we can improve the fit of our model, enhancing its predictive accuracy and reliability. This process is a crucial part of data analysis, emphasizing the importance of not only building models, but also rigorously testing and refining them. Next page. In our data analysis, we used a normal quantile plot, also known as a QQ plot, to assess the normality of the residuals in our model. This plot is a powerful diagnostic tool that compares the distribution of our residuals to the expected distribution if they were perfectly normal. In an ideal scenario, the points in the QQ plot should lie approximately on a straight diagonal line. In our case, we observed that the points did indeed follow this pattern. This alignment indicates that the distribution of our residuals closely matches the normal distribution, suggesting that our assumption of normality holds true. The normality of residuals is a key assumption in many statistical models. including linear regression. If this assumption is violated, it can lead to inaccurate estimates and unreliable predictions. Therefore, our finding of normal distributed residuals is a positive indication of the robustness of our model. Next page. However, it's important to remember that while the normality of residuals is a desirable property, it's not the only factor to consider when assessing the quality of a model. Other aspects, such as the significance of predictors and the overall fit of the model, are also crucial to consider in a comprehensive evaluation of our model's performance. We calculate the variance inflation factor, VRF, for all variables. The VRF values were all under 5 or 10, suggesting that there is no significant multi-collinearity among these variables. This finding is crucial as multi-collinearity can inflate the variance of the regression coefficients, making them unstable and difficult to interpret. Now comes to the forecasting part. In our predictive model, we have a specified interval of 114.4411 to 118.3627. This interval represents the predicted range for the air quality index. The model takes into account various factors such as particulate matter, PM10, or O3, or NO2 and CO. For instance, if we put the following values into our model, PM10 equals 84, and O3 equals to 54, NO2 equals to 14, and CO equals to 5. Our model predicts that the air quality index on that day would fall between this range. And this prediction is based on the relationships our model has identified between these variables and air quality. However, it's very important to note that these are statistical predictions, and actual values may vary due to other factors not included in the model. Nonetheless, these results provide valuable insights into the factors influencing air quality and can guide efforts to improve it. Now let me introduce our last member.
Continuing to our conclusions, in our study was targeted to use the comprehensive analysis of the 10-year air quantities data in Beijing to investigate the correlations between the mean pollutants, include the PM25, PM10, O3, CO, NO2, and SO2. Then the result was very interesting through the regression model and the collinear diagnostic within the R-code. The finding the severest important instead, then we can see the normal QQ plot of the residual in the back pages. On the other hand, show linear patterns through the conferring the assumption that the results were normal distributed. Secondly, the VIF, the variance inflation factors values were calculated to determine the no collinears among the pollutants. Particularly, every VIF values was less than the thousandth of the 5 or 10. In plain, this result was an insignificant correlation between the variables. Those results evaluate the reliability of the regression model and in place the accuracy of the substance forecasting analysis. Then continue to the next pages. Our study used the perspective the modeling methods for forecasting of the polluting levels in the future based on the including the pollutants. By making use of those factors, furthermore, the forecasting analysis is not only benefit in evidence the perspective investigates, but also is evidence the politics maker and the stakeholders the acknowledge both insight into the future air quality trend. which allows them to make informed decisions on the environmental management strategies and provide more effective protection for the people's response to disaster. Finally, in the next pages, in our conclusion, the air quantities become better over the past decades in Beijing due to the many results in our real life. In the future, there are the needs for long-term monitorings and data analysis benefit increasing the gradually those continually active are effective not only for the development of the effective polluting mitigating measures, but also for the promotion of the substance urban development. That is Beijing and the other cities which face similar environment problems. Through reorganizing those funding, gaining in the study, and by the continuing a solid strategy of the using data dividend method, stakeholder can make together to a cleaner, healthier, and a more subsistent urban future worldwide. Okay, so here is our presentation. Thanks for the watching.